Recording's rolling. It is Thursday, October 2nd. Today's course going to be an Aleks day. You guys have an Aleks number due tomorrow on 31, 23, 23. A lot of you guys have good progress on that. Guys, also keep in mind, in about 8 days is the end of the first quarter. So you're 30% high goals due. Guys, double check. Make sure that if it says 30%, it's not 30% of the 30%, in which case you're only about a third of the way there, because that's easy to trip up on. Right? So double check. Okay. Oh, I have returned you guys' module 2 quizzes to your folders. So if you want to do quiz corrections, you got partial credit back. If you have any questions how to solve any of those, of course, we'll be walking around today helping you guys out on any of the stuff. Really. Okay. And then tomorrow we're going to do an outside activity. So come dress for outside. Here, I'll show you guys what we're doing. Okay, so this is a projectile launcher that I've been using in my physics classes. We'll be using these tomorrow. Okay, so you guys, works like this. You guys see there's a spring in here. You can load in a ball. You guys see, so you guys ever look up here? So you know what's going on tomorrow? Yeah. Okay. Now, if you put in the squishy bouncy ball and then you ramrod it and press the spring, guess where the squishy ball gets stuck? Inside the launcher. And that's no good. You don't want that, right? Okay. So, guys, so ramrod it first. You guys listen real close. Listen. You guys hear it click? Yeah. Okay. That's this one right here. It says short range. But, ooh, what? Medium range?
Can we launch it in the
long
class?
range? Huh?
Can we launch it in the class?
What? Here, I'll do one class slot for you guys. Okay. So, guys, double check. Do you want to ramrod it first or put in the squishy ball first?
Put the squishy ball in first.
Ramrod first. Ramrod first. Okay. Then I'll put the squishy ball after the fact so it doesn't get stuck. Okay. And then, oh, hey, I got a lever right here. So pull this up. And ow! Out it goes. Okay, so now, how does this connect to what we've been doing? Well, this week, you guys have seen a lot of parabolas. Right? 3-1 was drafting quadratic questions. That was parabolas. 3-2, solving quadratic equations. You guys, when you were solving these quadratic equations in 3-2, really you were finding what are the x-intercepts? Here, guys, come here.
Oh.
X-intercepts of a parabola. And the word puzzles say defaulted to where, like, if you throw a ball straight up, how much time does it take to reach the ground? And ground level could be at height 0, which is like the x-axis. Okay? So the setup tomorrow is going to go like this. Okay. We're going to take the launcher out on the balcony. Okay. And fire the balls off the balcony. Now, I need to show you the physics setup first, which is a little different because it's going to connect and make sense. Okay. So what I had my physics students do was to aim it horizontally and spot where the ball landed. Right. So there was this height of the balcony, there was this distance, and based on that, they were able to get the launch speed. Right. Now, for you guys, I'm going to do something a little different. Right. Although, here, guys, what shape should this be right here? If I do this down, guys, what shape does this make? A parabola. It does. As gravity pulls down, it's a parabola. Okay. Now, you guys, I'm going to have you guys angle it up at some angle. You can measure that with a protractor, right? Like how many degrees from the horizontal. Okay. And then fire it. And instead, I'm giving you guys, I'm giving you guys the launch speed. Now, my physics classes got anywhere between 8 and 10 meters per second. So let's go with the middle value of like 9 meters per second. So go ahead and use that. You can measure whatever this angle is, theta. It might be like, eyeballing it, might be about 50 degrees right there, right? But you could do 20, 30, 40, 50, whatever you want to do. And this ball's going to do something like this. Right? It'll still reach ground level. Eventually, of course. Guys, is this still a parabola? It's still a parabola. Okay. And I'll tell you some other things too. In my physics classes measured the height of this balcony, they got about 4 meters. Notice I'm using metric units, like meters per second, meters. In your textbook was giving you like American units in terms of feet. Right? Speaking of which, gravity field. So in terms of feet per second squared, that's like 32. But in metric system, guys, does anybody know the value of Earth's gravity field in metric units? Because in feet, it's like 32 feet per second squared. But in metric, it's like 9.8. Guys. Come here. Meters per second squared downward. And I've taken my physics class, we'll talk more about that, but I'm just giving you guys the number and the connection to your map that you guys did here this week. Okay. So what you can do is you can set up a height versus time equation. And back from the book, you guys remember height is a function of time. It's like straight out of your book, so you guys can solve these this week. It turns out to be half of Earth's gravity. So guys, what's half of 9.8? Okay, 4.9. Okay. So that'd be meters per second squared. I'm going to hold down positive, so I'll leave that as positive. Well, yeah, let's get. Never mind. I'm going to hold down negative. Never mind. Okay. So again, that's just kind of what you put in. Now, in the vertical direction, it's not actually the full blast speed. It's it ends up being the sine component of the blast speed. Okay, so this right here is the initial in the y direction, which turns out to be 9 meters per second times sine of whatever this angle is. And that fits in right here. So you know what you do? I should show you guys the general form of following. Okay. So it's height as a function of time equals negative 1/2 gravity times squared. Oops, squared. Okay. Plus the initial in the y direction, t plus h initial. Right. That's again straight out of your book or you did physics. Okay, guys. Okay. So I got 4.9, so negative 4.92 squared off gravity. And then right here for v naught y, you can use 9 meters per second times sine of this angle. So you'll take a protractor there and say, what angle did I plot it at? Okay. So you do have to plug in some number of degrees, right, and there. Okay. And then that times however much time it would be in the airport. And then plus this h naught is, so the initial height is 4 meters. Okay, you guys get that? Okay. Now, if your question is for it to hit the ground, how much time to hit the ground? Guys, when it hits the ground, what's the height at ground level? What's the height at ground level? 0 meters. And look at that. You have a quadratic setup, don't you? Because 0 equals something t squared plus something t, right, plus something. And once you plug in the angle, the only thing you wouldn't know is the amount of time t. You see that? Right? So isn't t equal to, if it's like a, b, and c, could you set up a quadratic equation? Like negative b plus or minus the square root of b squared minus 4ac, all collectively divided by 2a. For this case, 2a would turn back into like gravity, wouldn't it? Go with that. Yeah, all right, so that'll be it. All right, so that'll be tomorrow's activity. So be ready for that tomorrow. But today, I'll walk around, help you guys out. You guys got this, Alex. You guys got this, Alex. You guys got quiz corrections if you want to do those. And I'll be walking around helping you guys out today.